Hi students, I think we are live. Just let me know if I am visible and audible to all of you. Just give me a thumbs up in the chat section if everything is fine with my stream. I think everything is fine. So now we can start our session. So sorry guys for this delay. There was some technical issue. So we are resolving that. Now I hope everything is fine. So let's start with our today's session. So guys, we are going to revise complete propositional and their first order logic. And I am taking uh, so after this session, I'm hoping that you are going to solve all the questions from this topic propositional and first order logic. Okay, so first of all, the most important thing is that what is proposition, right? So what do you call it as a proposition? So if I'll say proposition is a basic building block of logic, it is defined as a declarative sentence that is either true or false. Like if I'll say 2 is an even number, that is a proposition because it is either true or false. 2 is a even number, it is a true statement. Let's suppose if I'll say 3 is an even number, 3 is an even number, this is a proposition, right? This is a false statement, but it is proposition because I can give the truth value to this statement, either true or false, right? I can say that this is a true statement or false statement, right? Similarly, if I'll say that if I'll say, let's suppose ki I'll say x is an even number. Now I do not know what is x here, right? I cannot say that this is a true statement or false statement. So this is not a proposition. When it will be proposition, when I can guarantee that the statement is true or false. Like if I'll say the sun rises from the east, this is a true statement, so it is a proposition, right? Similarly, if I'll and the truth value, this true or false, I'll call it as a truth value of a statement, right? So but the important thing is that how we are going to connect any two or more proposition, that single proposition will not help us to move forward. हम क्या करें सिंगल प्रपोजिशन से? तो इसलिए हमें आइडिया है, क्योंकि हो सकता है दो तीन स्टेटमेंट को हमें मिक्स करना पड़े. द वर्ड्स फ्लाई इन द स्काई एंड आई हैव टू कनेक्ट दैट टू इज एन इवन नंबर. तो मुझे अगर दो स्टेटमेंट्स कनेक्ट करने पड़े तो मुझे कुछ कनेक्टिव्स की जरूरत पड़ती है. लाइक अगर हम बात करें दो या दो प्रपोजिशंस को हम ज्वाइन करें तो वो कंपाउंड प्रपोजिशन होते हैं, और उनको ज्वाइन करने के लिए मुझे जरूरत पड़ती है लॉजिकल कनेक्टिव और लॉजिकल ऑपरेटर्स की. जैसे कि हम यहाँ पे देख सकते हैं 1+1 इज इक्वल्स टू 2 एंड ऑल बर्ड्स कैन फ्लाई. ठीक है, अब ये दोनों प्रपोजिशन है, ये एक प्रपोजिशन है, ये एक प्रपोजिशन है. इसकी ट्रुथ वैल्यू ट्रू है, इसकी ट्रुथ वैल्यू ट्रू है. हमने बीच में किससे कनेक्ट किया? एंड से. सिमिलरली बी इज अ वोवल और ई इज अ वोवल, तो हमारे पास दो प्रपोजिशन हो गए और उसको हमने कनेक्ट किया और प्रपोजिशन से, राइट? तो इस तरीके से किन्हीं भी दो स्टेटमेंट्स को कनेक्ट करने के लिए हमें कनेक्टिव्स की जरूरत पड़ती है. तो अब इंपॉर्टेंट पॉइंट आते हैं कि कनेक्टिव्स होते कितने तरीके के, तो वो भी देख लेते हैं. ठीक है, जल्दी जल्दी रिवाइज करेंगे, फिर हम क्वेश्चंस करेंगे. अगर हम कनेक्टिव्स की बात करें, हमारे पास 5 टाइप्स के कनेक्टिव्स होते हैं: नेगेशन, कंजंक्शन, डिसजंक्शन, कंडीशनल एंड बाय कंडीशनल. सो लेट्स स्टार्ट फ्रॉम नेगेशन. व्हाट इज नेगेशन? If P is a proposition, then negation of P is denoted by negation P, right? And which when translated to simple English mean it is not the case. Let's suppose if I'm saying 2 is an even number, then its negation will be 2 is not an even number, right? And if I'll talk about the truth table, right? What is a truth table? If I'll take all the cases in which it would be true or false, that would consider as a truth table. So here I can see that if P is true, then negation P will be false. If P is false, negation P will be true. So the proposition's truth value gets converted into the opposite truth value, right? So that is our negation. Now if I'll move forward, next we have conjunction. Conjunction is basically and. So for any two proposition P and Q, conjunction is denoted by this sign and, which means P and Q, and its truth value will be it will be, yeah, if I'll see here, it will be true when both the propositions are true. If P is true, Q is true, then it's P and Q will be true. Otherwise, in all other cases, it will be false. If P is true, Q is false, we'll get a false. If P is false, Q is true, I'll get a false. P false, Q false, I'll get a false. So in conjunction, I'll get a true statement when both the propositions are true. And in disjunction, next is disjunction. It says that for any two propositions P and Q, their disjunction denoted by P or Q. This is a sign for or, which means P or Q. And how can I draw the truth table for this statement? So again, four cases. Why are we? Just one important thing, that why we are getting four cases. You can see when we have one proposition P, I am getting 2 to the power 1, two cases. When I have two propositions PQ, I am getting 2 square, four cases. If I'll have PQR, three cases, that would be 2 to the power 3, 8. And why I'm taking two? Because true and false, we have two choices here, right? So now for disjunction, if I'll see disjunction, so disjunction is false when both the proposition are false. Otherwise, if one of the proposition is true, disjunction gives me true, right? Truth value true. So this is disjunction. Now next two connectives we have is, first is implication. So for any two proposition P and Q, the statement if P then Q is called implication. Guys, this implication proposition is very important, right? And guys, one more thing, in the mid of the session, if you have any doubt, you can ask me in the chat section, right? Please ask me in the chat section if there is any confusion at all. Okay, so now next thing is if P then Q, it's called an implication, right? The most important thing, that how you read if P then Q, right? That is important, because in English statement we can write if P then Q as if P comma Q, Q if P, right? Q when P, Q whenever P, P only if Q, right? Now you can see here that we have written P only if Q. Now students get confused. We have written Q after if. Can they write Q implication P? Right? No. Because if we have only, then I'll write P implication Q. Just don't get confused with Q if P and P only if Q. Right? Don't get confused. That is the main point. Okay. Now next thing we have is Q unless negation of P. So just remember guys, that these are the English statement which they can use in questions to ask question from you, and we'll see in previous year question you will find some of the patterns from here. So just remember these points so you do not get confused in implication formula. Okay, next thing is, so if I'll see here in implication, this P is called hypothesis and Q is called antecedent, right? Now the important thing is the how to find out the truth value, because at the end we have to work on truth value, right? Okay, so P implication Q, I know that they are saying that P implication Q means if P then Q, that means if P is true then Q will be true, right? This is a statement na? So that's why when we have P true Q false, we are getting false, otherwise we are getting true, because if we have taken hypothesis correctly, then we can also conclude correctly. So if we'll get P true, hypothesis true and conclusion false, that would be my false statement. Otherwise in all other cases I'll get a true statement, right? I hope this is clear. Okay, so just let me know guys if there is any confusion at all, and uh, just ask me in the chat section if there is any confusion at all. Okay, so yeah, now we have last connective, which is biconditional. Let's see, biconditional or by implication. It says that for any two propositions, the statement P if and only if Q is called biconditional, and it is denoted by P if and only if Q. Now, this P if and only if Q means that if P happens, then Q happens. If Q happens, then P happens. So it will be true when both P and Q have same truth value. If they have distinct truth value, the statement will be false. Right? You can say that they are equivalent statement. Yeah, this is a truth table. You can see that if P and Q both are true, I'll get a true. If P and Q both are false, I'll get a true. Otherwise, I am getting a false statement. Right? So this is my propositions. This is my connectives. And one more thing, just see this. P if and only if Q have same truth value as P implication Q and Q implication P. Right? What does it mean? That if P is happening, then Q is happening. If P, then Q, and Q if P, and if Q, then P. Right? And we can check this using truth table. Right? So if I have to check the truth value of a statement, I'm going to use truth table, right? So here I have to check that this p if and only if q or this statement has same truth value or not. So let's see from the truth table. Okay, so you can draw the truth table by yourself. Let me draw it here. If I'll take p implication q, that would give me true, false, true, true, right? If I'll take q implication p, right, that would give me true, true, false, and true. Now, if I'll take the and of this statement, these two, so that would be p implication q and q implication p, and you will get this, you will get the same truth value here. So if you get the same truth value, so that means they are biconditional or double implication, right? So this is equivalent to p if and only if q is equivalent to if p then q and if q then p, right? So yeah, so these are all the connectives. Now we have special conditional statement, right? What are those special conditional statement? There are three related conditional statement that occur so often that they have special names. So they occur so often, so we have given them a special name. So what are these? Converse. The converse of the proposition is p implication q is q implication p. That means I have taken the converse of the statement. If p then q, it become if q then p, right? Now the next thing is contrapositive. It says that p implication q, negation of q, implication negation of p. That means if p then q is is if negation of q, implication negation of p. This is my contrapositive. Third one is inverse. The inverse of the proposition is p implication q. That will be negation of p, implication negation of q. Now we, in the difference between contrapositive and inverse is that we have changed the position of the proposition, right? In this inverse we haven't changed the proposition, only taken the negation, right? Okay, next thing is you can take that screenshot in a short form. This is basically statement converse, contrapositive, and then its inverse, right? Okay, truth table. Now you can check this truth table. If we have p and q, these are the cases I have. If I'll take negation p, negation q, I can find out p implication q from here. That would give me true, false, true, true, and I can find out negation q, implication negation of p, q implication p. So I can find out all the truth value. This is my statement, right? This is my statement. This is my contrapositive, contrapositive, right? This is my converse, and this is my inverse. Now I can see that statement and its contrapositive both have same truth value, right? Both have same truth value. You can check from here, and you can also check from here that converse and inverse also have same truth value, right? Statement and its contrapositive have same truth value, converse and its inverse have same truth value, and I can check that they have same truth value. And one more thing we have, that if two statements have same truth value, I can say that they are propositional equivalent. So I can say that p implication q is equivalent to negation of q, implication negation of p. That means they are equivalent. This is a sign of our equivalence. Similarly, I can say that q implication p is equivalent to negation p, implication negation of q, right? So this is all about propositional equivalence, right? So let's see further. Okay, now we have divided proposition into three types. And what are those three types? Let's see. First is tautology. A proposition which is always true is called a tautology. So if we have a proposition which will always be true, then I'll call it as a tautology. Let's suppose if I'll take p or negation p, it will be always true, p or negation p. You can find out the truth. Let's see, let me write here. Let's suppose I have p. So I'll have two cases, true, false. If I'll take negation p, I'll have false, true. If I'll find out p or negation p, it will be true and true. So that means I'll get truth value true in all the cases, so that means it is a tautology. It is a tautology. Now, next thing is contradiction. The statement which is always false, a proposition which is always false is contradiction. So here, if I'll find out P and negation P, let's say I'll find out P and negation P, you can check that it will be always false. True and false will be false, false and true will be false. So this statement will be contradiction. Now, contingency, a proposition that is neither a tautology nor a contradiction. That means it has both true and false in the truth table, right? In the truth table column. So that would give me a contingency, right? So it's easy. Let's see some question based on these, right? So this is my question. It says that uh, this proposition is a tautology, contradiction, contingency, or absurdity, right? I have to check that it is what. So you can check it by truth table, right? And how would you find out? So if you will see this P implication Q and Q implication Q, we have discussed before 2 slides that this is basically P if and only if Q, right? And if you would find out the truth value for P if and only if Q, that would be true, 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 false, false, true, false, false, right? And the truth value of P if and only if Q will be true, false, false, and true, right? So we have both true and false in the last column, right? In the truth value of this. So this is basically our contingency. If we got all the truth value true, so that means if we'll get truth value true in all the cases, that is a tautology. If we'll get all the truth value false, that would be a contradiction. Otherwise, it is a contingency, right? Okay. Absurdity means that it doesn't get defined. Okay. So guys, let's see this question. It says that, let's see this question. It says that this is a question from GATE CS 2014. It says that good mobile phones are not cheap. Second statement is cheap mobile phones are not good. P implies Q, Q implies P, and end statement is P is equivalent to Q. So we have to tell them which one of the following about L, M, N, and N is correct, right? So can I translate this English sentence into a propositional logic, right? Then I can check, right, that these L, M, and N are correct. If the truth value is true, then they are correct, otherwise they are not correct, right? I can do that. So good mobile phones are not cheap. Let's take these good mobile phones as let's say good mobile phones as G and cheap as C, right? Cheap mobile phones are not good. So that means first P statement will be good mobile phones are not cheap. That means G, if they are good mobile phones, then they are not cheap, right? That's how we'll write. Q statement is cheap mobile phones are not good. Cheap mobile phones are not good, right? Cheap, if they are cheap, then they are not good, right? You have to convert this statement like this, that they you have to understand that they have given implication. Good mobile phones are not cheap. That means if the mobile phone is good, then it is not cheap, right? That's how I find out that I have to use implication. Now next thing is P implies Q. P implies Q, that means this. Q implies P, and P is equivalent to Q. So I can see that P if and only if Q, right? Let's check. So if I'll take G and C, or let's take all the cases. If I'll take GC, true, 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 false, false, true, false, false. These are all my cases, right? I have to find out G implication, negation C. That would give me, let's find out negation C here. That would be false, true, false, true. G implication, negation of C will be true, false, will give me false, true, true, give me true, 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 right? Let's find out negation of G. That would give me false, false, true, true, right? Now I have to find out C implication, negation of G, right? C implication, negation of G. That means these two. True, false gives me false, and true, false, oh, sorry, false, false gives me true, true, true gives me true, false, true gives me true. Now I have to find out P implication Q. This is my P, this is my Q. I have to find out P implication Q. This is completely based on truth table. You have to solve it using truth table. There is no other option. Just use true, false correctly. Just do these things correctly. Then you can easily solve this question. False implication false, true. True implication true, true implication true, true implication true. Similarly, if you will find out Q implication P, you will get true, 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 true. If you will find out P if and only if Q, you can check from here that P and Q both have same truth value at every point. So that would give you true, 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 true. So that means L, M, and N. What are these? This is my L, this is my M, this is my N. Right? All three statements have truth value true in all the cases. That means L, M, and N are correct. So that means which option is correct here? Option D is correct. So guys, if you will see here, that question is not at all difficult. What they have done, they have used implication twice in every statement, right? We have implication here, implication here, implication here, implication here. That means we have statement inside the statement. P is G implication negation of C, then they have defined L, right? So we have used implication twice in every case, so that's why we felt that it was difficult. Otherwise it's not at all difficult. We just have to go through the truth table with the truth table. I hope it is clear. If you have any doubt, please ask me in the comment section. And if you are learning from this session, please like the session so that it can reach to more students. I know you have waited a long, but you will get the wait will be worth. I am going to complete this propositional order, right? So yeah, let's move forward. Okay, next we have is propositional equivalence. As I told you, what is propositional equivalence? If two statements have same truth value, I'll say that they are propositional equivalent, right? So yeah, I also can say that if they have same truth value, then this will be always true. So I can say that this will be a tautology. Let's suppose what I'm saying here, that let's suppose P and Q, I'm saying that P and Q are propositionally equivalent. That means they have same truth value. If they have same truth value at every point, then this will be true in every case. And if it is true, then it will become a tautology, right? This is a definition in a different way. So I hope it is clear. Let's see. One way of proving that is to use a truth table. Better way is to construct a mathematical proof which uses already established logical equivalences. Okay, so guys, one more thing. Let's suppose if I am getting three proposition P, Q, and R. I told you that my number of cases will be 8. Okay, that will be enough to handle, right? But if I'll have 4, then I'll have 16 cases. Okay, that would be a little bit difficult, but let's suppose we can handle 16 cases. But let's suppose if I'm getting 5 cases, then it will become 32. That's not going to handle using pen and paper, right? That would be very difficult for us. So what would I do? I'll use some laws which have been established before, and I'm going to use them by name. Like you have studied in mathematics, commutativity, uh, distributive law. I'm going to learn these type of laws, and we are going to use in propositions. Okay, so let's see what are these laws, because that would make, you will see that these laws will make our work very easy. So first is identity law. Identity law means if I'll take P and true, it would give me P. You can see using truth table. If I'll have P is true, P is false. P and true will give me true and false. False, right? I am getting a false. So that means this will become a same as this P. So that is basically by identity law. P and true will give me P, P or F will give me P. Similarly, I'll have domination laws. P and F will give me false. P or true will give me true. You can see here, let's suppose P and false. P is true, false. False is false in every case. If I'll find out P and F, I know that if one of the proposition is false, I'll always get a false. So that's why I'm getting a false. Similarly, you can find out for true at the same time. Idempotent laws. If you are getting P and P, that would be equivalent to P. P or P, that would be again equivalent to P. Guys, you have studied this double negation law in probability also, right? Instead of negation, you have studied complement. So that is exactly same. It is negation of negation P, right? What is negation of negation P? P. Okay. Next thing is commutative law. If I'll write P and Q, that would or equivalent to Q and P. P or Q, that would be equivalent to Q or P. Similarly, we'll have associative law. If we have same sign, if we have and or same sign, then I can change the bracket position. P, if I'll solve P and Q before, and then later on it will give the same result as P and Q and R before, right? Similarly for this one, Q and R. Okay, next we have is distributive laws. P and Q or R can be distributive as P and Q or P and R. Similarly for or and end. Absorption law, this is important, guys. If you are not going to remember this absorption law, because this is a little bit difficult to remember, just see identity laws. If you have remembered, we have discussed that P and true, P and false. Okay, let's not see right now. Identity law. Just see, P and P or Q will give me P, P or P and Q will give me P, right? So what happening here, you can see using P or Q, true, 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 false, false, true, false, false, right? Let's find out P or Q. That would give me true, 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 false. And if you will take P and P or Q, you will get true, true, false, and false, right? So that's why I'm getting the same probability, same truth value as P. So that's why they are same. So these are my absorption law. Next thing we have is negation law. P and negation P will always be false. P or negation P will always be true, right? So let's see some question based on these laws, and then we'll see how we are going to apply these laws. One more important law is P implication Q is negation of P or Q. Just check by yourself that this law is true or not, and you are going to learn this rule first once you have go through the truth table of this law, right? Okay, next we have is DeMorgans law. You have studied this DeMorgans law in probability also. Instead of negation, you will have a complement, right? This is what negate, and instead of and, you will have intersection. Instead of or, you will have union, right? So that is similar. Negation of P and Q will give me negation P or negation Q. Negation of P or Q will give me negation P and negation Q, right? That is my DeMorgans law. Okay, so if I want to see the truth table, I can check here. This is my truth table. Let's see. P and Q will be, I can see here true, false, 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 because P and Q will be true when P and Q both are true, right? Now, the next thing is negation P or negation Q. If I'll find out this will give me this result. And if I'll take negation of P and Q, that would same, right? So that's why this, you can check by yourself this proof by truth table, right? Just go through this yourself, you will get the result. Now let's try to solve this question. Just go through this question once and let me know how to solve this. You have to use propositional equivalence laws. Okay, so if you will see here, they are saying that P and Q are two proposition. Which of the following logical expressions are equivalent? Okay, so if you will see that they have given us very long statement. If you try to solve it using truth table, that would be very difficult for us to solve it. So what would you do? You are going to use propositional equivalence laws. So if I'll see this first statement is P or negation Q, right? So this is simplified. I cannot simplify it furthermore, right? Can you simplify first statement more? Can you simplify it more? No, we can't simplify P or negation Q. So what will we do? We'll take the second statement. Second statement says that negation of negation P and Q. I know that I can apply DeMorgans law in this statement. What would it become? Negation of negation P and Q. So that would become, it is equivalent to negation P, or, and will become or, and it will become negation Q, right? Is it clear? Negation of negation P and Q or negation Q. What we have done? We have used DeMorgans. So let's write it down here that we have used DeMorgans law. DeMorgans law. Right? Now, negation of negation P will be P because of double negation. So we'll get P or negation Q because of double negation. Now I can see that I got the same statement as in one. So that means they are equivalent to each other, right? So that means I do not have to apply long tables. I have to do not have to take 4 cases in each column, and then and instead of doing that I have just solve it in 2 steps, right? Now I can solve it same for the third statement. Let's do that. Let's see what we can do in the third statement. What is it? P and Q, or P and negation Q, or negation P and negation Q. So what I can do here, I can take P common using distributive law, right? In the third statement I can take P common. What would I left with? If I'll take P common, I'll left with P or Q. If I'll take common P and Q or negation Q, right? And the last term remains same, negation P and negation Q. Now if you remember, using negation laws, Q or negation Q, Q or negation Q will always be true. Q or negation Q will always be true. How? Let's see. Q, true false. Negation Q will become false true. If I'll take Q or negation Q, it will become true or false will be true, false or true. So that means it will become always true, P and true, or negation P and negation Q. Now this P and true, let's see. If I'll take, let's take P and true. Let's suppose if we do not remember the laws, I am taking in that case. If P is true, if this is true, I'll get a true. If P is false, P and true, right? If P is false, I'll get a false. So that means this will give me nothing same as P. It will give me nothing more. It will give me as same as P. So can I write it here, P or negation P and negation Q, right? Now, can I use distributive law here? Right, I can use distributive law. What would I do? I'll get here P or negation P and P or negation Q, right? P or negation P will be, we have seen that Q or negation Q will always be true. So if I'll take P or negation P, it will be true and P or negation Q. Now if I'll take true and with any of the proposition, this is complete one proposition. If I'll take T and, I have seen if I have P one proposition and I have taken and true, it will give always the proposition as P. So here I'll get the proposition as this one, right? T doesn't matter here. So what would I get? I'll get P or negation Q. This is what? This is nothing but my first statement. So this is also equivalent. Can you tell me guys, fourth statement is equivalent or not? Fourth statement is equivalent or not? Just give me the answer in the chat section, guys. Right, Kavya. Answer B is correct. Why answer B is correct? Because fourth statement is not equivalent. Why? How do you know that? How do I know that it is not equivalent? I haven't solved it, right? Because I have seen that. I have seen here that this P and Q, it's same. P and negation Q is same, or sign is same. We have just one sign difference here. We have here negation Q, and here we have Q. So if I'll make a small change in this fourth one, if I'll try to convert it in fourth one, it will become Q. If I'll remove it, it will become Q, it will become Q, it will become Q, right? And it will become Q, it will become Q. So it will become Q. So we are left with P or Q, which is not equivalent to a third statement. So this is my fourth statement, right? This will become my fourth statement, and it is not equivalent to my first statement. That's why my fourth statement is not equivalent. Only first, second, third statement are equivalent, and here that's why option B is correct. I hope this question is clear, because we have used almost all the laws in the question. Just let me know if there is any confusion. Otherwise, I'll move forward to next question. Guys, before moving on, please like the session and share it with your friends so that they can learn further, which we are going to learn in this session. Okay, so let's see next question. Yeah, this is next question. Consider the following propositional statement. Which one of the following is true? P1 is a tautology but not P2. P2 is a tautology but not P1. P1 and P2 both are tautologies. Both P1 and P2 are not tautologies. Just let me know, guys. How would you going to solve this question? How you are going to check that this is not a tautology? Are you going to solve it using truth table? Are you going to solve it using truth table? No, that's not going to happen, because we have three A, B, C, three propositions here, and that would make it very difficult for us to solve using truth table, right? We'll have 8 cases, and we have so many connectives here, so we have to work on each of the connective. So what would I do? If you remember, we have one implication law which says that P implication Q will be equivalent to negation P or Q, right? So I'm going to use this. So let's see this P1 statement left hand side. What would I'll have? I'll have A and B implication C, right? So can I use here negation of A and B or C? That means negation, if I'm going to use DeMorgans law here. So what would I get? I'll get negation of A or negation of B or C, right? Is it correct? And will become or, right? Now, because of DeMorgans law, and here I have used implication, right? Now, can I use here distributive law? What would I get? Negation of A or C, or negation of B or C, right? So what would it become? A implication C or B implication C. So that means this A and B implication C is equivalent to A implication C or B implication C. So that means they are not equivalent, because we have and sign here. So this P1 statement is not equivalent, right? So P1 statement is not a tautology. If they will become equivalent, then it will become a tautology, right? It will be true in every case. Just try it once that P2 is not a tautology, or P2 is not a tautology. Just check it. Guys, check once P2 is a tautology or not. How we are going to go through that P2 is not a tautology. Just let me know in the chat section if you will get P2 is a tautology or not. Yeah, so this is simple. You just have to take A or B. That means there will be a distinct sign here, here, and here we'll have, yeah. If you will see, this will remain same if I'll convert it, if I'll take A or B, right? This will become four. This is my second statement. This will become or, this will become and, this will become and, this will become and. Now if I'll imply uh, distributive law here, I'll get here and I'll get here and. Now you can see that we are getting here and they have given us or, so that means it is also not a tautology. So here option D is correct. Both P1 and P2 are not tautology, right? Kavya and Harsh, your answer is correct, that P1 and P2 both are not tautologies. Okay, let's, if there is any confusion, guys, please ask me. Otherwise, I'll move forward to next question. Okay, so let's see next question. Yeah, so guys, try this once and let me know what will be the answer here. What is this question? It says that consider the following expression: false q, true p or q, negation q or p. The number of expressions given above that are logically implied by p and p implication q. So that means we have to find out the out of these five expression, how many number of expression are logically implied by this statement. Just try this once and let me know the answer in the chat section. Just let me know, guys, the answer in the chat section. Right, let's see. Let's see this question. We have number of expressions that are logically implied by P and P implication Q, right? So what would I do? I'll solve it. Let's say P, I'll have two propositions here, P and Q, right? So this is my P and this is my Q, right? So we'll have true, 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 false, false, true, and false, false. That means we'll have four cases, right? Let's first find out the truth value of this. So what would I'll get? P and P, let's find out P implication Q. P implication Q. What would I get? True, false, true, true, right? This is a truth value of P implication Q. If I'll find out P and P implication Q, that would give me true, false, true, sorry, that would be false, and this will be false. Is it correct? Right? Is it correct? Now, the next thing we have is first, second, third, fourth, fifth statement. So let's suppose this is my A statement. I have to check that A implication first is true or not. A implication first is true or not. What is first? False. So A implication false. So that means true implication false will be false. It will be true, true, true. It's not, first is not logically implied because I am getting false in the first case, right? This is not a tautology. So I'll say that this is not logically implied. So this is not true. Let's say Q. A implies second. That means A implication Q. What is this A and this second column is Q. True implication true, true. False implication false, true. False implication true, true. False implication false, true. So I am getting true in every case. So that means it's logically implied, right? So it is logically implied. Now third statement is A implication third. So that means A implication true. So let's see. False, what is A? A is this true implication true? True. False implication true? True. False implication true? True. So I am getting true in every case. So this is also logically implied. Now, fourth option is P or Q. So let's first find out the truth value of P or Q. So let's first find out fourth. Let's first find out fourth, truth value of fourth. Fourth is what? P or Q. That would give me true, 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 and false. Now, A implication fourth, right? So, what will be A implication fourth? A implication, this is A and this is fourth. True implication true, true. False implication true, true. False implication true, true. False implication false, false. True. Sorry. So I'll get I'll get true in every case. So this is also logically implied. Now, next thing is negation Q or P. Let's first find out the truth value of negation Q or P. That would give me true, true, false, and this will be true, right? These are the truth value. Let's check it once. False, I'll get a true. Here I'll get a negation Q. Yeah. So this is my fifth statement. Right now I have to check A implication fifth. So what is A? True, false, false, false. So let's see. True implication true, true. False implication true, false implication false, false implication true. So I'll get true in every case. So fifth is also logically implied. So I can count here that four statements, second, third, fourth, fifth are logically implied. So 4 is my correct answer. Right? So I hope all of you get it. Why 4 is correct answer? Right, Harsh, your answer is correct. 4 is correct answer here. I hope it is clear to all that why 4 is a correct answer here. Right? Okay. So that's how you have to check. This was an easy question completely based on truth table. You have to understand that what is the definition of logically implied and you have to go through the set of expressions one by one. The problem student faced in these type of question, they do not understand what question is saying. So they are trying to check each one of them and they face difficulty in these type of questions. If you have any confusion, guys, please ask me in the chat section. Otherwise, I'll move forward. Okay, so let's move forward. 4 is the correct answer here. Okay, so the next topic we have here is rules of inference. That is very important topics because from this topic they have asked so many questions in previous year, and also this rules of inference topic is going to help us in quantifier and predicate logic. So just study it carefully. Right? So rules of inference is basically we have premise and conclusion. In this premise, it says that it is a proposition on the basis which we would able to draw conclusion, right? If you remember, we have studied this implication, P implication Q. This is what? If P then Q. So here P plays the role of premises and Q plays the role of conclusion, right? So P is a premise. So premise is an evidence or assumption which we take. Q, conclusion, it is a proposition that is reached from the given set of premises. Now in implication we have only one premise and one conclusion. Here we have many number of premises, right? Now from number of premises I have to conclude something. So yeah, so this is our premise or conclusion. If premise then conclusion. Now as I told you that premise implication conclusion is what? P implication Q. but as I told you before that we can have number of premises, p1, p2, p3, p4 up to pn. We can have number of premises, but how I can conclude? I can conclude some conclusions from these premises. Let's suppose I'll have here p1, p2 up to like this. We have pn proposition, and from these premises I'm concluding some conclusion q, right? So first of all of these premises has to be true, then we can check that conclusion is true or false, right? If I'm concluding something, if you remember, if I have taken p implication q here, so if p is true, अगर ये p true है, then हम conclusion सही या गलत कर रहे हैं तब हमें पता चलता है, ठीक है? अगर p true है q false है तो हम कहते थे गलत हो ही नहीं सकता, क्योंकि अगर premise true है तो हम conclusion उससे गलत नहीं निकाल सकते, राइट? तो इन सारे premises को true होना पड़ेगा ना, और इन सारे प्रीमिसेस को ट्रू होना पड़ेगा, लेकिन अब मैं चाहती हूँ कि इसको मैं एक स्टेटमेंट में कन्वर्ट कर दूं। इसको मैं एक स्टेटमेंट में कैसे कन्वर्ट कर सकती हूँ? ऐसे, इफ आई टेक दिस स्टेटमेंट लाइक दिस, p1 एंड p2 एंड अप टू pn इम्प्लीकेशन q। अब अगर आप याद करो कि ये ट्रू और ये फॉल्स होगा तभी मेरे को फॉल्स मिलेगा, अदरवाइज मेरे को हमेशा ट्रू मिलेगा। अब ये ट्रू कब होगा? जब ये p1 ट्रू हो, p2 ट्रू हो और pn ट्रू हो। सो दैट मींस हर एक प्रीमिसेस को ट्रू होना पड़ेगा कंक्लूजन के सही होने के लिए, तो उसके लिए मैंने एंड लगा दिया, क्योंकि मुझे पता है कि एंड तभी ट्रू होता है जब सारे प्रीमिसेस ट्रू हो, मतलब उसके सारे प्रोपोजिशंस ट्रू हो, अदरवाइज एंड ट्रू नहीं देता है, ठीक है? अगर एक भी प्रीमिसेस गलत होगा तो ये फॉल्स हो जाएगा स्टेटमेंट, अगर ये फॉल्स हो गया तो कंक्लूजन फॉल्स हो ट्रू हो, मेरे को तो ट्रू स्टेटमेंट मिलेगा, राइट? ठीक है, आई होप दिस इज क्लियर। ओके, ठीक है। Argument is valid if whenever the premises are all true, conclusion must also be true, right? अगर premises true है और conclusion भी true है तो हम उसको tautology बोल देंगे, अगर premises true है और conclusion false है तो हमारा false statement हो जाएगा, ठीक है guys? अगर यहाँ तक कोई problem नहीं है तो give me a thumbs up guys, then we'll move forward. Just give me a thumbs up if there is no confusion, then we'll move forward regarding questions of these premises and conclusion. ओके सो गाइस, आप लोग कुछ भी प्रॉब्लम हो पूछ सकते हो चैट सेक्शन में, ठीक है? चलिए, ठीक है। अब ना कुछ रूल्स ऑफ इन्फ्रेंस है। अब क्या प्रॉब्लम हो क्या रहा है कि रूल्स ऑफ इन्फ्रेंस क्या कह रहे हैं कि अगर मेरे पास नंबर ऑफ प्रीमिसेस हैं तो मैं उनसे कुछ कंक्लूड कर लूं, क्योंकि पर्टिकुलरली हर एक प्रीमिसेस पे जाके और फिर कुछ कंक्लूड करना तो प्रॉब्लम हो जाएगी। तो हो सकता है मैं कुछ रूल्स ऐसे पहले से प्री डिफाइन कर दूं जिनसे मेरे क्वेश्चन बहुत ईजी हो जाए, राइट? क्योंकि ऐसे तो हर एक बार बार जाके करना तो प्रॉब्लम रहेगी ना। तो अगर आप यहाँ पे देखो, कुछ कुछ रूल्स ऑफ इन्फ्रेंस बहुत ईजी है। अब क्या कह रहे हैं कि P है और P इंप्लीकेशन Q है। अगर मेरे पास ये दो प्रीमिसेस है, मतलब P है और P इंप्लीकेशन Q है, तो मैं कंक्लूड कर सकती हूँ कि Q भी ट्रू होगा। अगर ये दोनों स्टेटमेंट ट्रू है, P एंड P इंप्लीकेशन Q ट्रू है, तो मैं कह सकती हूँ कि Q भी ट्रू होगा, राइट? तो और ये कौन सा रूल है? ये है मॉडस पोनेंस। अब आप चेक कैसे कर सकते हो? चेक करो भाई, P है और P इंप्लीकेशन Q है, P ट्रू है, लेट्स सपोज Q ट्रू और फॉल्स नहीं, इसको इससे चेक नहीं कर सकते, आप ऐसे चेक कर सकते हो। लेट्स सपोज P Q ट्रू 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 फॉल्स फॉल्स ट्रू फॉल्स फॉल्स, ठीक है? अब मेरे को क्या चाहिए? P इंप्लीकेशन Q, तो मुझे क्या मिल जाएगा? ट्रू फॉल्स ट्रू ट्रू। अब मुझे एंड करना है P एंड P इंप्लीकेशन Q। अब देखो आप, P एंड P इंप्लीकेशन Q इन दोनों के लिए ट्रू फॉल्स एंड दिस विल गिव मी फॉल्स एंड दिस विल गिव मी फॉल्स, ठीक है? अब अगर मैं P एंड P इंप्लीकेशन Q, अब ये किस में ट्रू है? ये इसमें ट्रू है ओवरऑल, और इस केस में Q भी ट्रू है, ठीक है? मुझे बस यही देखना है। तो मतलब इन दोनों प्रीमिसेस से मुझे ये कंक्लूजन मिल रहा है Q, ठीक है? सिमिलरली अगर मैं मॉडस टॉलन पे हूं, ये क्या कहता है कि P इंप्लीकेशन Q है और नेगेशन Q है, तो मुझे नेगेशन P मिलेगा। मतलब कि अगर मेरा, अगर देखो पी और पी इम्प्लीकेशन क्यू में क्या था कि पहले वाला पी सेम था, इसमें बाद वाले में नेगेशन है, तो मुझे नेगेशन ऑफ पी मिल रहा है, वो क्या है, मेरा मॉडस टॉलन। सिमिलरली मेरा हाइपोथेटिकल साइलोगिज्म कहते हैं कि अगर पी इम्प्लीकेशन क्यू कर रही हूँ, क्यू इम्प्लीकेशन आर कर रही हूँ, तो मुझे पी इम्प्लीकेशन आर मिल जाएगा. दैट इज माय हाइपोथेटिकल साइलोगिज्म. दैट मीन्स इफ यू रिमेंबर यू हैव स्टडीड these टाइप ऑफ लॉज लाइक ट्रांजिटिविटी इन रिलेशंस इन सेट थ्योरी, राइट? So अगर next rule है disjunctive syllogism, it says that if we have negation p and p or q, right? Negation p and p or q, so that means we'll have a q statement, this q statement, right? We can conclude q. This is what, this is my disjunctive syllogism, right? So these are the laws, rules of inference. ठीक है, we have some more rules, which is first is addition. I can add any proposition using connective or. If you will see, we have single p here, I have added p or q. You can add any proposition using or connective. Exportation is basically if I have p and q implication r, I can write it as p implication q implication r, right? I can do that. Next we'll have dissolution, which is p or q, negation p or r, we'll left with q or r. That means which is same and have negation in one of them, we can eliminate that, right? We left with q or r. Okay, so we have this question based on rules of inference. Just see this and let me know if you are able to solve this question. Just try this once. It is completely based on rules of inference. Okay, so if you will see this question, it is saying that S1 statement is if a candidate is known to be corrupt, then he will not be elected. Second statement says that if a candidate is kind, he will be elected. Which one of the following statement follows from S1 and S2 as per sound inference rules of logic? Right, so we have given some statements and we have given uh, the conclusion from these two statements, and we have to check that which of the statement will be true. So if I'll take candidate is corrupt, let's take p as candidate is corrupt. Candidate is corrupt, right? Let's take q as he is kind. He is kind, right? Let's take r as let's take r as he will be elected. He will be elected, right? Now I can translate these English sentences into propositional logic. Can I do that? Can anyone from you tell me that how can I write S1 statement? Can you tell me, guys, how can I write S1 and S2 statements? Okay, so if you will see this, it is saying that if a candidate is known to be corrupt, that means P, then he will not be elected. That means P implication negation of R, right? If a candidate is kind, then he will be elected. Candidate is kind, that means Q implication he will be elected, R. If a candidate is kind, he will be elected, right? Now you can see here that we cannot use any of the rule in these two statements because they are not going to combine using rules of inference. So what I can do here is, can I write from these two statements, this three statement, negation of R, implication, negation of Q? What I have done here, I have taken the contrapositive. Right, Kavya. Right? uh, I have taken this contrapositive in the second statement, taking contrapositive, and we know that contrapositive is always equivalent, right? We have seen when we have started equivalence, right? And when we have worked on truth table, we know that that contrapositive have same truth value, so I have replaced that. So now can I combine these two? Can you remember, do you remember which rule we can use here to combine these two? If you remember, we have used hypothetical syllogism, right? Which have combined two statements, p implication negation of r, and here negation of r implication negation of p. So that would give me p implication negation of q. 1, 3 में हमने लगाया है hypothetical syllogism. Hypothetical syllogism, this rule which we have used here. और इसमें हमने सेकेंड में लगाया कॉन्ट्रापोजिटिव. कॉन्ट्रापोजिटिव, ठीक है. अब क्यू पी इम्प्लीकेशन नेगेशन ऑफ क्यू, मतलब हम इसको ऐसे लिख सकते हैं कि पी क्या था हमारा, कैंडिडेट इज करप्ट, क्यू मतलब ही इज नॉट काइंड. इफ कैंडिडेट इज करप्ट देन ही इज नॉट काइंड. लेट्स गो थ्रू द स्टेटमेंट. If a person is known to be corrupt, then he is kind. This is not the statement we are looking for, because our statement is if a person is corrupt. Let me write here. If a person is corrupt, then he is not kind. He is not kind. ठीक है. If a person is not known to be corrupt, he is not kind. Again, wrong statement. If a person is kind, then he is not known to be corrupt. If a person is not kind, then he is known to be corrupt. So if you will see here that this in kindness, this C and D statement, in C and D statement, you can see that kindness comes forward, right? Here we have corruption is in starting the statement, and here in C and D we have kindness in start the statement. So that means we have to change the places. So how I can change this negation of q and negation p implication negation of q, taking contrapositive. Can I take the contrapositive here? What would I get? Negation of negation q, implication negation of p. That would be my contrapositive. Double negation will become q implication negation of p. Now this will become if a candidate is kind, then he is not known to be corrupt. So if a candidate is kind, he is not known to be corrupt. C is correct, D is not correct, right? So just remember guys, if you have in starting another statement, you can change the place using contrapositive, and then you can easily answer those type of questions. Just let me know if this is clear, otherwise I'll explain it again. Just let me know guys in the chat section. Let me know guys if there is any confusion at all in this question, otherwise I'll move forward to the next question. And guys, after this session you can attempt a contest which is based on these questions, these topics, on the link given in description, and that link is also pinned in comment section, so that you can revise all the concept once again, right? And also you can apply for GATE test series. You will get all the free all the test, subjective test, 22 subjective test, and free mock test, and 22 subjective tests and full mock test. Also the link given in description. And guys, if you want a short notes, free short notes you will get in this contest. Okay, so let's move forward if this question is clear. Okay, just try this question once and let me know which option is correct here. Guys, let me know in the chat section. This is a similar question which we have answered before, and let me know in the answer in the chat section. Okay, so let's see. It says that consider the following in logical inferences. First statement, L1 statement says that if it rains, then the cricket match will not be played. The cricket match was played. Inference, there was no rain. So that means, uh, yeah. So if I'll see this question, it says that if it rains, then cricket match will not be played, and the cricket match was played. So that means we'll have here two inferences, two premises, and then we'll have a conclusion here that there was no rain. In I2, it says that if it rains, then the cricket match will not be played. That means we'll have again two premises, and second one is it did not rain. The conclusion or inference from there will be the cricket match was played. So we have to tell them which of the following option is true. So what would I do? If I'll see, let's take it rains as P. Let's take P as it rains, Q as cricket match played. Right? Now let's translate these sentences into English, into propositional logic. So if I'll take I1, so this is what, if it rains, then the cricket match will not be played. If it rains, then cricket match will not be played. Right? This is my first premise. If I'll take the second premise, this is cricket match was played. That means we'll have Q. Right? So that means they have concluded that there was no rain. That means negation of P. So we have to check that from rules of using rules of inference that the statement is true or not. Right, Kavya? P implication, negation of Q will be our first premise. Right? I have to check that I can get this negation of P from these two statements. So let's see. So if you remember, we'll have a double negation rule that I can apply double negation Q from 2. Double negation. What I have done, I have used double negation instead of Q. Now, if I'll take this here, like this, you can see that I can apply modus tollens here. Negation of this whole will give me negation of P, right? 1,3 modus tollens. जस्ट लेट मी नो किसी को अगर फोर्थ स्टेप समझ नहीं आया है कि हाउ डिड आई राइट फोर्थ स्टेप. लेट मी नो इन द चैट सेक्शन कि अगर किसी को भी यहाँ पे कोई कंफ्यूजन है कि हाउ आई हैव रिटन दिस नेगेशन ऑफ पी. ठीक है, अगर ये नेगेशन ऑफ पी आ गया, यही तो हमें चाहिए था, यही तो मेरा कंक्लूजन था. राइट? अगर यही कंक्लूजन था तो मतलब ये स्टेटमेंट ट्रू है. इससे जो भी इन्फ्रेंस हमने लिया है वो सही इन्फ्रेंस लिया है. ठीक है, समझ में आया गाइस? ओके. अगर किसी को कोई भी कंफ्यूजन है, आस्क मी इन द चैट सेक्शन. ठीक है, आपको सब क्लियर होना चाहिए जो भी यहाँ पे चल रहा है, क्योंकि आपने यहाँ पे टाइम दे रहे हो, हमने वेट भी किया इस सेशन के लिए. ठीक है, चलो I2 पे चलते हैं. I2 क्या कह रहा है? I2 कह रहा है इफ इट रेन्स देन क्रिकेट मैच विल नॉट बी प्लेड. ओके, लेट्स राइट डाउन द फर्स्ट प्रीमिस. If it rains, that means if it rains, then cricket match will not play. Again, P implication negation of Q was the premise. Second premise will be it did not rain. That means negation of P. And they have concluded that cricket match was played. That means Q. Would that be true? Can I conclude this Q from this these two premises, these two given premises? Can I conclude that? No, we can't conclude that because we don't have any law which says that negation of P implies negation of negation Q, and that would give me Q. So there is no law at all because we have studied all the laws of inference. We did not encounter any kind of law. So that means I2 is not a correct inference. So here option B is correct, which says that I1 is correct inference and I2 is not. I hope this is clear to everybody. Okay, so let's move forward. Right. Okay, so guys, we have studied propositional logic. Now we have predicate logic. So we have to remember all the things which we have studied in propositional logic to cover the concepts which are given in predicate logic. Right? So let's see. So what is predicate? So that is important. Predicates are the statement involving values which are variables which are neither true nor false until or unless the values of the variables are specified. So that means if I'll specify a certain value to a statement, then it will become true or false. Otherwise, this the statement does not have any truth value. How? If you remember, we in starting I have taken one example, which is x is an even number, and I told you I cannot specify any truth value at this point. Can I specify? Because I do not know what this x is. So what we call this x is a variable here, right? So that's why I haven't assigned any truth value. Let's suppose if I'll assign x is equals to 2. So it will become 2 is an even number. 2 is an even number. Now its truth value is true, right? And you can notice here that assigning one truth value, one variable, one value to this variable, it will become a proposition. Now it is what? It is a proposition. In starting it is not a proposition because it does not have any truth value. Now it is a proposition, right? Similarly, let's take x is equals to 3. Then I'll write 3 is an even number. Now it is my false statement. It is a proposition, but we have this as a predicate. So I hope now you know what is a predicate, in which we'll have a variable, and assigning the value to the variable, we'll get a proposition, right? Okay. So yeah. Next thing, this is a open statement, right? The example which I have taken above, the same example I have written down here, right? Okay. Right, and we'll have subject and predicate in this statement. This x is a subject and predicate variable, and the later part is a variable predicate, right? And one important thing here is that I can denote this as p of x, where p and this brackets implies that it is an even number and x is a subject. Let's suppose if I'll take p of 2, that means 2 is an even number. Let's suppose if I'll have p5, that means 5 is an even number. If I'll take px, that means x is an even number, right? That's how we specify, that's how we give the notation to a predicate. Okay. Okay, so important thing is that we have some have to specify the truth value to those predicates also, right? At the end we have to specify the truth value, otherwise this x is an even number does not helping me in solving question if I cannot specify any truth value to the statement, right? I have to first specify x as a single variable. Then there is no need to study about predicate logic, which I have studied of a single value in propositional logic. So that means this has to give some information to me about the truth value, right? So that's why we'll have here two quantifiers, universal quantifier and existential quantifier, right? How do they work? Let's suppose we'll have this statement px. It says that x plus 2 is greater than x. Let's check. If I'll take x is equals to 1, 1 plus 2 greater than 1, true. 2 plus 2 greater than 2, true. 3 plus 2 greater than 3, true. So अगर आप इस statement को देखो, this is true for every x. I can check that px is true for all values of x, right? So that's where we use our universal quantifier. If I'll write for all x px, if I'll write for all x px, so that means it is true for every x. It is x is true for every value, right? Because हमें लास्ट में तो ट्रूथ वैल्यू पे काम करना ही है ना, तो यहाँ पे क्या हो पा रहा है, यहाँ पे मैं काम कर पा रही हूँ सारी ही ट्रूथ वैल्यू पे एक साथ. तो लेट्स सपोज मेरा कोई स्टेटमेंट है कि द सन राइजेस इन द ईस्ट. हमें पता है कि वो ट्रू स्टेटमेंट है. उसी तरीके से मुझे किसी वेरिएबल के लिए काम करना है. तो अगर लेट्स सपोज कि मैं किसी कॉलेज के एक वो ले लेती हूँ, एक लिस्ट ले लेती हूँ, एक कॉलेज की लिस्ट ले लेती हूँ जिसके स्टूडेंट है. तो अगर मैं बोलूँ कि एक्स इज अ स्टूडेंट फ्रॉम दिस कॉलेज और मैं उन बच्चों के नाम चेंज करती रहूँ, तो हमेशा ट्रू होगा क्योंकि वो स्टूडेंट है उस कॉलेज के, मैंने लिस्ट वहीं से उठाई है. तो इसका मतलब ये भी है कि डोमेन इंपॉर्टेंट है. क्योंकि लेट्स सपोज कि अगर मैं एक कॉलेज का नाम ना लेके, कॉलेज की लिस्ट ना लेके, अगर मैं 10 कॉलेज की लिस्ट ले लूँ और तब मैं लिखूँ कि एक्स इज अ स्टूडेंट फ्रॉम दिस आईआईटी, then that would be wrong. लेट्स सपोज कि भाई मैं लिख रही हूँ कि एक्स इज एन स्टूडेंट फ्रॉम आईआईटी दिल्ली, स्टूडेंट फ्रॉम आईआईटी दिल्ली, ठीक है। अगर मैं दिल्ली की लिस्ट उठा रही हूँ आईआईटी दिल्ली की, तब तो ये हमेशा हर किसी के लिए ट्रू होगा। लेकिन लेट्स सपोज मैंने सारे आईआईटीज की लिस्ट उठा ली, तब तो ये स्टेटमेंट फॉल्स हो जाएगा ना, ठीक है। तो इसलिए ये इंपॉर्टेंट है कि डोमेन क्या ले रहे हैं, राइट। यहाँ पे डोमेन बहुत इंपॉर्टेंट है, तो उसी का हमें ध्यान रखना है कि कभी भी जब स्टेटमेंट की बात हो कि वो लोग डोमेन क्या ले रहे हैं, ठीक है। एक ये एग्जांपल है, अगर मैं यहाँ पे देखूंगी, अगर x ग्रेटर देन 10 लिया है, तो अगर मैं 5 6 7 ले रही हूँ तो वो तो फॉल्स आएंगे। जैसे ही मैं 11 से लेना शुरू करूंगी तो ट्रू हो जाएंगे स्टेटमेंट। तो मतलब ये कुछ वैल्यूज के लिए ट्रू है और कुछ के लिए फॉल्स है, ठीक है। तो इस तरीके के दो क्वांटिफायर है। वो वाला था हमारा फॉर ऑल एक्स पी एक्स, यहाँ पे सारी वैल्यूज के लिए ट्रू था। यहाँ पे हम लिखेंगे कि भाई ये ट्रू है, देयर एग्जिस्ट एक्स पी एक्स, मतलब यहाँ पे कुछ वैल्यूज हैं, और देयर एग्जिस्ट एक्स मतलब एटलीस्ट एक वैल्यू तो है जिसके लिए पी एक्स स्टेटमेंट ट्रू है, ठीक है। तो हम लोग ये करते हैं कि देयर एग्जिस्ट एक्स पी एक्स इन केस वेयर वी हैव सम वैल्यूज विच आर ट्रू, सम वैल्यूज विच आर फॉल्स, ठीक है। अगर सारी वैल्यूज ट्रू हो जाएंगी तो हम लोग फॉर ऑल एक्स पी एक्स लिख देंगे, ठीक है। एक बार डिटेल में देख लेते हैं इनके डेफिनेशन। यूनिवर्सल क्वांटिफायर, और हाँ, यूनिवर्सल क्वांटिफायर, mathematical statement sometimes assert that a property is true for all the values of a variable in a particular domain, right? That's what I told you, in a particular domain, right? Domain is very important and we call this as domain of discourse, ठीक है। तो domain important है, such a statement is expressed using universal quantifier, ठीक है। px for all values of x in the domain, तो हम लिख सकते हैं for all x px। यहां तक सबको क्लियर है? यहां तक बताओ गाइस, सबको क्लियर है? तो हम लोग एग्जिस्टेंशियल क्वांटिफायर पे मूव करें, अदरवाइज एक बार और क्लियर कर लेते हैं। लेट मी नो गाइस, अगर किसी को कोई भी कंफ्यूजन है या फिर अगर क्लियर है तो भी बताओ चैट में मुझे, एटलीस्ट आई विल नो कि भाई इतना हम लोग पढ़ा रहे हैं आपको समझ में आ रहा है कि नहीं आ रहा है। ओके, हर्षित सिंह क्लियर नाउ। और स्टूडेंट्स को क्लियर है? व्हाट अबाउट अदर स्टूडेंट्स? Guys, in the middle of the session, if you have any doubt, please ask me and just respond if you are learning, right? Let's move on to uh, existential quantification. Right, this is my existential quantification. It says that some mathematical statement assert that there is an element with a certain property. Such statements are expressed by existential quantification. मतलब some property, some अगर हम कह रहे हैं कि there exists some, then it will be a existential quantification, right? So existential quantification of px in the statement means there exists at least one x in the domain such that px, right? Again, domain matters. There is an x in the domain such that px for some x px. They can give us anything like this. We have to understand that they are talking about existential quantification. Okay, there exists x px. Okay. Now let's see this question. Now what I have to do, I have to convert this statement into propositional logic. I have to translate this English sentence. Anybody from the chat section can tell me that what will be the answer here? Can anyone tell me that what will be the correct translation of the statement? Some real numbers are rational. The statement is some real numbers are rational. Right. Let's see. We have given that some real numbers are rational. That means कुछ रियल नंबर है जो रेशनल है, तो हमें तो पता है देयर एग्जिस्ट यूज होता है। लेट्स सी, तो फॉर ऑल वाला तो ऑप्शन गलत ही होगा। सो फर्स्ट देखते हैं, देयर एग्जिस्ट एक्स, रियल एक्स और रेशनल एक्स। सो दैट मींस देयर एग्जिस्ट एक्स, दैट एक्स इज रियल और एक्स इज रेशनल, बट दैट इज नॉट ट्रू। हमें क्या बताना है कि कुछ रियल नंबर्स हैं जो रेशनल है, राइट। तो यहाँ पे क्या हो रहा है कि या तो एक्स रियल है या तो एक्स रेशनल है, तो वो तो हमारे को नहीं चाहिए। थर्ड स्टेटमेंट देखते हैं, देयर एग्जिस्ट एक, फोर्थ देखते हैं पहले, देयर एग्जिस्ट एक्स, रेशनल एक्स इंप्लाइज रियल एक्स। ये क्या कह रहे हैं कि कुछ एक्स ऐसे हैं कि अगर वो रेशनल है तो वो रियल है। भाई ये क्या बात हुई, हमें तो बात ये करनी थी ना कि रियल है तो रेशनल है, तो ये तो गलत हो गया। अगेन अब अगर थर्ड वाला स्टेटमेंट देखें तो वो बोल रहे हैं देयर एग्जिस्ट एक्स सच दैट एक्स इज रियल एंड एक्स इज रेशनल। तो मतलब क्या बोल रहे हैं कि अगर कुछ एक्स ऐसे हैं कि या एक्स रियल है और एक्स रेशनल भी है, मतलब कुछ एक्स ऐसे एग्जिस्ट कर रहे हैं कि एक्स हमारा रियल भी हो रहा है और एक्स हमारा रेशनल भी हो रहा है, स्टेटमेंट ट्रू हो गया, सम रियल नंबर्स आर रेशनल। देखो अगर आप देखोगे तो आपको ऐसा लगेगा कि इंप्लीकेशन जैसा रूल है, ठीक है, लेकिन आप ऐसे नहीं लिख सकते देयर एग्जिस्ट एक्स रियल एक्स इम्प्लीकेशन रेशनल एक्स, ये गलत हो जाएगा आपका। कोई आप में से बताएगा कि ये गलत क्यों हो जाएगा? क्योंकि देखो अगर आपको याद हो, कोई आप में से बताएगा कि ये स्टेटमेंट क्यों नहीं लिख सकती मैं एक बार, अगर लेट सपोज कि ऑप्शन में ये होता कि आप इसको टिक करते? क्योंकि देखो अगर आप देयर एग्जिस्ट एक्स ऐसे लिखते हो, नेगे, आपको पता है कि पी इंप्लीकेशन क्यू क्या होता है, नेगेशन ऑफ पी और नेगेशन ऑफ पी और क्यू, ठीक है। तो अब क्या हो जाएगा अगर आप देखोगे तो नेगेशन ऑफ रियल एक्स और रेशनल एक्स, ठीक है। अब देखो अगर आप यहाँ पे देखते हो नेगेशन ऑफ रियल एक्स और रेशनल एक्स, इसका क्या मतलब हो, कुछ एक्स ऐसे एग्जिस्ट कर रहे हैं कि या तो वो रियल नहीं है या तो वो रेशनल है। ऐसा कोई नंबर होगा कि अगर वो रेशनल हो लेकिन वो रियल नंबर ना हो, या फिर रियल नंबर ना हो और वो रेशनल हो, ठीक है। तो कंडीशन फॉल्स हो जाएगी कि देयर डज नॉट एग्जिस्ट, कि वो रियल नहीं है और वो रेशनल है, ठीक है। ऐसा तो कोई भी स्टेटमेंट एग्जिस्ट नहीं करेगा कि या तो वो रेशनल हो या तो वो नॉट रियल हो, कोई एक्स ऐसा एग्जिस्ट करेगा ही नहीं कि वो नॉट रियल है, ठीक है। तो चलिए, और हमारा स्टेटमेंट ये कहता था कि सम रियल नंबर्स आर रेशनल, तो वो कंडीशन यहाँ पे जस्टिफाई नहीं हो रही है। तो जब भी देयर एग्जिस्ट की बात आती है हमेशा एंड यूज करते हैं, ठीक है। जब भी देयर एग्जिस्ट की बात आती है हम लोग एंड यूज करते हैं, हमेशा याद रखना। C is option correct. Okay, guys, let me know the answer of this question. Just try this once again, based on quantifiers. Just try this question once and let me know the answer in the chat section. Okay, so if I'll see this question, it says that which one of the following is the most appropriate logical formula to represent the statement? Statement is gold and silver ornaments are precious, and they have represented gold using gx, precious using px, and silver using sx, right? So how do I attempt this question? So here if you will see, let's see first, for all gold and silver ornaments are precious, so that means we will have for all, क्योंकि सारे ही ornaments precious, या तो वो gold है या तो वो silver हो, तो देयर एग्जिस्ट वाला तो हटा ही देते हैं, देयर एग्जिस्ट वाला हम लोग हटा देते हैं। तो फर्स्ट से चलते हैं, फॉर ऑल एक्स पी एक्स इम्प्लीकेशन जी एक्स एंड एस एक्स। अब हमारा स्टेटमेंट था गोल्ड एंड सिल्वर ऑर्नामेंट्स आर प्रीशियस, ये बोल रहे हैं कि प्रीशियस है तो वो गोल्ड एंड सिल्वर होगा, तो ये तो गलत हो गया, हमें तो ये चाहिए ही। बी वाला स्टेटमेंट देखते हैं, कह रहे हैं कि फॉर ऑल एक्स जी एक्स एंड एस एक्स इम्प्लीकेशन पी एक्स। अब क्या बोल रहे हैं कि हर एक एक्स के लिए एक्स इज गोल्ड एंड एक्स इज सिल्वर देन इट इज प्रीशियस। अगर कोई भी एक्स गोल्ड और सिल्वर दोनों होगा तब वो प्रीशियस होगा। ये चीज गलत नहीं हो गई, क्योंकि एक्स इज ईदर गोल्ड और एक्स इज ईदर सिल्वर। ये क्या मतलब हुआ कि एक्स इज बोथ गोल्ड एंड सिल्वर, तो बी स्टेटमेंट भी फॉल्स हो गया। डी स्टेटमेंट सही है। ये क्या बोल रहा है, फॉर ऑल एक्स जी एक्स और एस एक्स इम्प्लीकेशन पी एक्स। तो गाइज अगर आप एक चीज नोटिस करोगे यहाँ पे एंड लिखा हुआ है, लेकिन अगर आप चेक करो तो यहाँ पे और आ रहा है, ठीक है। तो ये ध्यान रखना है, आपको ट्राई करना है, ऐसे नहीं कि सीधा सीधा आप एग्जैक्ट पढ़ के लगा दो, क्योंकि गोल्ड एंड सिल्वर क्या कह रहे हैं कि भाई गोल्ड भी प्रीशियस है और सिल्वर भी प्रीशियस है, ठीक है। तो दोनों प्रेशियस है, या तो वो गोल्ड होगा तो भी प्रेशियस होगा, सिल्वर होगा तो भी वो प्रेशियस होगा, ठीक है। तो दैट्स व्हाई ऑप्शन डी इज करेक्ट, राइट गाइस। So here D is my correct option. Okay. Yeah. Let's move forward. Here D option is correct. Now negation of quantified statement will be, if we have negation of for all x, that would become equivalent to there exists x negation of px. That means if I'll take the negation inside for all become there exists. Similarly, there exists will become for all x. So this is my similar statement, right? This is our negation of quantified statement. ठीक है, ये क्वेश्चन करते हैं एक बार. None of my friends are perfect. What would be the logical translation of this statement? None of my friends are perfect. Try this question once and let me know the answer in the chat section. Just go through the option one by one and cancel out the option and take the option which is correct. That would be the correct way to solve this question. Okay, चलो try करते हैं. Option A says that there exists x, fx and negation of px, and we have to translate the statement none of my friends are perfect. So it says that there exists some x who are friends and who are not perfect. But the statement is none of my friends are perfect, but it's saying that there exists some friends and they are not perfect, right? So A will be not true. If you will see it's saying that none of my friends are perfect. So this statement you can see, it seems like that there does not exist any friend who are perfect, right? There does not exist any friend. So there exists, if I'll see B statement, there exists x who is not a friend and who is perfect. Why do we care? We have to say that my friends are not perfect. So this B option will not be true. Similarly, C option, there exists x, that x is not friend, x is not perfect. हमें इससे मतलब ही नहीं है. हमें मतलब किससे कि मेरे फ्रेंड परफेक्ट नहीं है. अगर वो फ्रेंड ही नहीं है तो उससे काम ही नहीं करना है हमें, हमारा कोई काम ही नहीं है. यहाँ पे डी ऑप्शन पे आते हैं. Negation of there exists, that means there does not exist friend and there does not exist x such that x is a friend and x is perfect. This is the correct option, because यही स्टेटमेंट कह रहा है कि भाई मेरा कोई भी फ्रेंड परफेक्ट नहीं है, कि कोई भी एक्स ऐसा एग्जिस्ट नहीं कर रहा है कि एक्स वो फ्रेंड भी हो या वो परफेक्ट भी हो सकता है कि फ्रेंड हो तो परफेक्ट ना हो और परफेक्ट है तो फ्रेंड नहीं है. ठीक है, तो ये मेरा ऑप्शन ट्रू हो गया. तो हियर डी ऑप्शन इज करेक्ट. Right, Kavya, Rajan and Harsh, your answer is correct. ठीक है, आगे बढ़ते हैं. अब देखो गाइस क्या आता है, नेस्टेड क्वांटिफायर. अब हो क्या रहा है कि अब हो सकता है ना कि मेरे को दो वैल्यूज के साथ एक साथ काम करना पड़ जाए, दो वेरिएबल्स के साथ. अगर मेरा कोई भी स्टेटमेंट ऐसे हो x प्लस वाई इज इक्वल्स टू 4, तो x और y की दोनों वैल्यू पे डिपेंड कर रहा है ना इस स्टेटमेंट. अगर x1 है y3 है तो ये ट्रू होगा, x2 है y2 है तो भी ये ट्रू होगा, x3 y4 तब ये ट्रू नहीं होगा. ठीक है, तो x और y की कुछ कुछ वैल्यूज चेंज करके मेरा स्टेटमेंट की ट्रू और फॉल्स ले रहा है. ठीक है, तो एक से ज्यादा हमारे पास वेरिएबल हो सकते हैं किसी भी स्टेटमेंट में, किसी भी प्रेडिकेट लॉजिक में. तो उसी के लिए हमारे पास है नेस्टेड क्वांटिफायर. जैसे कि हमारे पास ये स्टेटमेंट है, फॉर ऑल एक्स देयर एग्जिस्ट वाई, एक्स प्लस वाई इज इक्वल्स टू 0. अगर हमारे पास टू प्रेडिकेट्स हैं तो हमें पास दो क्वांटिफायर भी तो चाहिएंगे हमें. ठीक है, फॉर ऑल एक्स फॉर ऑल वाई हो सकता है. ठीक है, इस तरीके से कोई भी स्टेटमेंट हो सकता है. तो वो हम अगर हम दो एक से ज्यादा क्वांटिफायर साथ में ले रहे हैं तो हम उनको बोलेंगे नेस्टेड क्वांटिफायर. ठीक है, अब देखो एक ये लिखा है कि इट इज पॉसिबल टू यूज टू क्वांटिफायर सच दैट वन क्वांटिफायर इज विद इन द स्कोप ऑफ अदर वन. राइट, वन क्वांटिफायर हैज टू बी स्कोप ऑफ अनदर वन। क्यों भाई, ऐसा क्यों बोल रहे हैं? क्योंकि अगर आप स्टेटमेंट को देखो, फॉर ऑल एक्स देयर एग्जिस्ट वाई, अब देखो ये क्या बोल रहा है, हर एक एक्स के लिए वाई एग्जिस्ट कर रहा है। लेट सपोज अगर एक्स 1 है तो इसको ट्रू होने के लिए वाई माइनस 1 हो जाएगा, एक्स 2 है तो इसको ट्रू होने के लिए वाई माइनस 2 हो जाएगा, ठीक है। दैट्स व्हाई दे आर सेइंग दैट द स्कोप ऑफ अनदर वन, ठीक है। ओके, तो बढ़ते हैं। The above statement is read as for all x there exists y such that x plus y is equals to 0, ठीक है। और इसको हम इस तरीके से लिख सकते हैं। अब डिफरेंट कॉम्बिनेशन क्या क्या हो सकते हैं? फॉर ऑल एक्स वाई क्यू एक्स वाई, फॉर ऑल एक्स देयर एग्जिस्ट वाई क्यू एक्स वाई, फॉर ऑल एक्स देयर एग्जिस्ट एक्स फॉर ऑल वाई क्यू एक्स वाई, एंड देयर एग्जिस्ट एक्स देयर एग्जिस्ट वाई क्यू एक्स वाई। अब देखो इंपॉर्टेंट पॉइंट यहाँ पे ये आते हैं कि द रिलेटिव ऑर्डर इन विच द क्वांटिफायर्स आर प्लेस्ड इज इंपॉर्टेंट unless all of the quantifier are of same time, that is all are universal quantifiers or all are existential quantifier. So what does it mean? अगर हम यहाँ पे देखें कि भाई हमारे पास क्या दिया हुआ है, फॉर ऑल एक्स फॉर ऑल वाई, इसको मैं ऐसे लिख सकती हूँ, फॉर ऑल वाई फॉर ऑल एक्स क्यू एक्स वाई। यहाँ पे ऑर्डर मैटर नहीं करता, क्योंकि कह रहे हैं कि कहाँ कहाँ मैटर नहीं करता, या तो दोनों यूनिवर्सल हो या फिर दोनों एग्जिस्टेंशियल हो। यहाँ पे ऑर्डर मैटर करता है। इसको मैं नहीं लिख सकती कि इक्विवेलेंट होगा देयर एग्जिस्ट वाई फॉर ऑल एक्स क्यू एक्स वाई, क्योंकि हम देख सकते हैं ना कि भाई मेरा स्टेटमेंट क्या था, एक्स प्लस वाई इज इक्वल्स टू 0, और मैंने इसको लिखा था कि फॉर ऑल एक्स देयर एग्जिस्ट वाई, ठीक है। अभी ये ट्रू है हमेशा, क्योंकि अगर x1 लोगे तो y माइनस 1 मिल जाएगा, y2 लोगे तो x2 लोगे तो y माइनस 2। लेकिन अगर मैं इसको क्वांटिफाई चेंज कर देती हूँ, फॉर ऑल x प्लस वाई इज इक्वल्स टू 0, ठीक है। अब देखो y मैंने लेट सपोज 1 ले लिया, तो x मैं कुछ भी लूं, x तो हर एक x के लिए ट्रू होना चाहिए था ना। दैट मीन्स अगर मैं y 1 ले रही हूँ तो मेरा स्टेटमेंट क्या बन जा रहा है, फॉर ऑल x प्लस 1 इज इक्वल्स टू 0, तो ये तो कभी भी ट्रू नहीं होगा। दैट्स वाई हम इंटरचेंज नहीं कर सकते। सिमिलरली इस केस में भी इंटरचेंज नहीं कर सकते, इस केस में कर सकते हैं। अगर दोनों यूनिवर्सल है, दोनों एग्जिस्टेंशियल है, तो हम इंटरचेंज कर सकते हैं, अदरवाइज उनका रिलेटिव ऑर्डर मैटर करता है, ठीक है गाइस। चलिए लेट्स मूव फॉरवर्ड। एग्जाम्पल टू कन्वर्ट द स्टेटमेंट इनटू अ नेस्टेड क्वांटिफायर। तो अब हमारे पास स्टेटमेंट है, देखो यहाँ पे ना नेस्टेड क्वांटिफायर यूज होगा। अब आपको पता कैसे चलेगा कि नेस्टेड क्वांटिफायर यूज होना है? लेट्स सी, देयर इज अ पर्सन इन दिस लेक्चर हु हैज टेकन एट लीस्ट वन कोर्स इन डिस्क्रीट मैथमेटिक्स। There is a person in this lecture who has taken at least one course in discrete mathematics. तो वहां पे एक person है, x and y are the person and the course in the respective quantifiers attached in front of them. अब देखो front में क्या attached है, there is a person, so that means there exists one person in this lecture who has taken at least one course. That means there exists some course which he or she has enrolled in discrete mathematics, right? तो हम ऐसे लिख सकते हैं, there exists x, there exists y, pxy, और pxy क्या है? For some x people there exists a course in discrete mathematics. For some x, ठीक है, for some x people, ठीक है। ओके, तो अब क्या करना है, हमें नेगेशन करना है इन क्वांटिफाइड स्टेटमेंट्स का, नेस्टेड क्वांटिफायर्स का। वो कैसे करेंगे? नेगेशन ऑफ नेस्टेड क्वांटिफायर विल बी, अब हमारे पास कोई भी ये स्टेटमेंट है, फॉर ऑल एक्स देयर एग्जिस्ट वाई, अगर हमें इसका स्टेट नेगेशन करना है, फॉर ऑल एक्स देयर एग्जिस्ट वाई, हम कैसे लिखेंगे? नेगेशन ऑफ फॉर ऑल एक्स देयर एग्जिस्ट वाई पी एक्स वाई, ठीक है। ये मेरा स्टेटमेंट हो गया, इसका नेगेशन करना है, तो क्या होगा? फॉर ऑल का देयर एग्जिस्ट हो जाएगा, देयर एग्जिस्ट का फॉर ऑल हो जाएगा, और नेगेशन पी एक्स वाई। इस तरीके से हम क्या करते हैं? नेगेशन करते हैं किसी भी नेस्टेड क्वांटिफायर का, ठीक है। तो नेगेशन का ये तरीका है। तो हमारा स्टेटमेंट अगर ये है, देयर एग्जिस्ट एक्स एट कॉर्नल सच दैट एक्स इज एट लीस्ट 18 ईयर्स ओल्ड, हम देयर एग्जिस्ट को फॉर ऑल में कर देंगे, और एक्स इज नॉट 18 ईयर्स ओल्ड, इस तरीके से हो जाएगा, ठीक है। अब हमारे पास ये स्टेटमेंट है गाइस, इसको सॉल्व करो, इसको ट्राई करो सॉल्व करने का। Just try this once to solve it. What they are saying. Suppose the predicate fxyt is used to represent the statement that person X can fool person Y at time t. Which one of the following statement expresses best meaning of the formula? Formula is for all X there exists Y, there exists T, negation of fxyt. X can fool person Y at time t. So अगर हम देखें that means for all X, इस negation को बाहर ले आते हैं, ठीक है? सबसे आसान रहेगा नेगेशन ऑफ, अगर हम इस नेगेशन को बाहर लेके आए तो हमारे पास बन जाएगा नेगेशन देयर एग्जिस्ट एक्स फॉर ऑल वाई फॉर ऑल टी एफ एक्स वाई टी, ठीक है? अब देखो स्टेटमेंट क्या बन रहा है, नेगेशन ऑफ देयर एग्जिस्ट, सो दैट मींस एक्स कैन फूल, सो दैट मींस देयर डज नॉट एग्जिस्ट एनी एक्स, दैट मींस नो वन कैन फूल एनी पर्सन एट एनी टाइम टी, राइट? So I can see here that this is everyone can fool, तो ये भी नहीं true होगा, ये भी नहीं true होगा, इनमें से देखते हैं. No one can fool everyone all the time. हाँ सही है, क्योंकि यहाँ पे भी for all है, यहाँ पे भी for all है, ये true है. अब देखते हैं इसको. No one can fool some person at some time. नहीं भाई, यहाँ तो for all है, तो ये तो नहीं true हो सकता. तो option B is my correct answer. Right guys, option B is correct here. Yeah, option B is the correct answer here. Right, so let's move forward. Okay, so guys, that's all from my side. That is all complete propositional logic. I hope all of you have revised complete propositional logic and clear all of your doubts and able to solve all the question. Just try to give the contest which have pinned in the comment section. And if you want to practice more questions and give the test series, you can find out the link in the description below. And in this test, in this GATE free crash course, you will get free notes and you will get contest and you will get lectures. I hope if there is any question, please ask me. Otherwise, I'll wrap up this session. Okay, so that's all from my side. Thank you.